nominal. The joke going around is the fact that the way we greet everybody is, how you doing today? Oh, I'm nominal. But it's you don't want anything to go wrong. You want it to work perfect. But you always are kind of apprehensive, prepared for the worst. But because we do a lot of testing on the ground beforehand, it's really not too much of a surprise that things work great. Because if we had a lot of problems with it, we wouldn't be flying it. You get it to where it's bulletproof here on the ground, then you fly it. And the main objective there is to find the things you either didn't think of, or you were just miscalculated when you were worrying about making the difference between a ground-based test versus an actual flight test. Something that has become almost iconic. By iconic, I mean representative of something maybe that has been lost in aerospace, is what you guys did just before the launch with that Merlin engine. Right, trimming the skirt on the Merlin vac. Yes, we had Marty Anderson and Flo Lee. Both of them, they went on up on one of our man lifts, crawled through the interstage door, got inside there. Marty pretty much laid it out. He did what he normally does at the shop here. The difference was he was up inside the vehicle, 100 feet up off the ground, inside the vehicle, doing the exact same thing. Those two were able to go through, get that thing ready to go, trimmed it up real nice. We cut up all the little pieces to feed it back out the door, and it's like it's ready to go. We're ready to fly. And we were doing this, up until, fairly close before we actually were getting ready to launch. Did that remind you at all? There was a story that we heard when we did PlanRad Live about, really, it was John Glenn's Atlas, I think. Correct. That we heard the story about crawling up inside and actually doing some welding. And I brought that up, that exact same story that we talked about on Planetary Radio. I brought that exact same story up while we were out there doing this. I said, look, guys, we're not the first ones to do this. And I kind of told the whole story about it. And they're like, you're kidding. It's like, no, history's repeating itself. And hopefully we'll have a successful flight just like John Glenn did, and it looks like we did. We're in a conference room right now. You spend most of your time, I assume, out there on the floor? Yeah, a little bit of both. Sometimes I'm stuck at the computer, which that gets boring. But the fun part is going out on the floor, making sure everything's working. A lot of times if technicians have questions, I'll be out there standing on my head looking at something to try to give them an answer to try to solve the particular issue. Can we head on out there, maybe? Yeah, let's head on out there. We'll be able to talk a little bit. I'll be able to show you some of our toys. Excellent. Well, we will take a quick break, and when we come back, we'll continue with Jeff Rokicki of SpaceX out on the floor where they are building those rockets and spaceships. This is Planetary Radio.
I'm Robert Picardo. I traveled across the galaxy as the Doctor in Star Trek Voyager. Then I joined the Planetary Society to become part of the real adventure of space exploration. The Society fights for missions that unveil the secrets of the solar system. It searches for other intelligences in the universe, and it built the first solar sail. It also shares the wonder through this radio show, its website, and other exciting projects that reach around the globe. I'm proud to be part of this greatest of all voyages, and I hope you'll consider joining us.
You can learn more about the Planetary Society at our website, planetary.org/radio, or by calling 1-800-9-WORLDS. Planetary Radio listeners who aren't yet members can join and receive a Planetary Radio t-shirt. Our nearly 100,000 members receive the internationally acclaimed Planetary Report magazine. That's planetary.org/radio. The Planetary Society, exploring new worlds.
Welcome back to Planetary Radio. I'm Mat Kaplan. We are out on the floor at SpaceX where they actually build this amazing hardware. Still with Jeff. And Jeff, we are looking at something magnificent that was not here the last time I got to visit.
What you're looking at here is all 9 of our engines attached onto our truss and skirt, and this goes onto the bottom of our first stage engine. Each one of those engines you're looking at has already been tested and is ready to go. This process, what you're seeing right now, is all 9 of them being integrated together, and then these are going to be heading on out. We will do an acceptance test of all 9 engines together, and this is for one of our future flights coming up.
And so you do that testing in Texas, right? You've got a facility there.
That is correct. We've got a facility out there. We'll make this up onto our first stage tank, bring it up to the top of our, what we call the tripod, and then run all 9 engines together at the same time, make sure everything's working correctly.
And if all goes well, this will at some point be part of a flight into space.
Definitely, this is flight hardware. We don't have too many parts just for looking around. It's everything we have here, we're using it because we're planning on flying it.
Speaking of things holding together, what's the condition now of the Dragon capsule, the one that was on what you call the C1 mission that was so successful?
Actually, I've seen it. It looks amazingly good. The sides of it, we jokingly said it looked like a toasted marshmallow. It's kind of brown on one side and a little bit darker on the other side. But the heat shields, we're going through, slowly disassembling it. We're going to go through it with a fine-tooth comb. But everything looks really, really good now. We're looking at all of our different temperature labels that we have inside to see how the temperatures performed. We're going to be cutting up little pieces of it to inspect it, make sure everything works out really good. But, we were saying it looks like we could probably put it back on there on top if we wanted to and probably fly it again.
And this heat shield, this ablative material where you guys kind of built on some NASA technology, improved it a bit?
That's correct, yeah. The PICA, the phenolic impregnated carbon ablator. Actually, we've got a newer version of it we call PICA X. We've tweaked the formula a little bit. Actually performs a little bit better than the original PICA developed by NASA Ames. It's worked really, really good. And when we were looking back at the capsule when it came back, this stuff worked like a champ. Really, really good.
Let me bring up a story you were talking about a few moments ago about the parachutes. And some stuff that I wasn't aware of, that you could actually come down on one parachute. I mean, they used to talk about Apollo was fine if it came down under 2. In fact, that was one of our trivia contest questions recently, because Apollo 15 did just fine under 2. But you guys are okay with even 1, but a lot of this came out of your study of what came before, of the Apollo program and other NASA programs.
That's correct. One of the things that was really good from an Apollo program is they cranked out just a ton of different documents called the Apollo Experience Reports. They would take some subsystem, let's say parachutes. They would write through it and give you a 40 to 50 page report. They all pretty much followed a similar format. They would talk about what was the subsystem, what were the requirements, what were the different ideas they looked at, why was it they chose the one they did, what were the problems they ran into during testing and flight, how did they fix them, and if they were doing it again, what would they do different? So it was really nice because in 40, 50 pages, you can quickly get up to speed on the whole history behind it and what worked and what didn't. And so we did a lot of research when we're putting both Falcon 9 and Dragon together so that we could do this. One of the things that was really kind of important on the parachutes was vehicles always have a tendency to get a little bit heavier than you first anticipate, so you might want to put a little bit bigger parachutes in than you originally expect. One of the things, they didn't do that in Apollo, and they had to jump through so many hoops to stuff those parachutes into a tiny, tiny little spot. So one of the things we took away from that was put really big parachutes on, and that really paid off a lot because it saved us a lot of weight on other components because our splashdown loads are so low because of that. And we can come down on one parachute and survive. We will be doing much better than Apollo did on 2 parachutes.
I've learned to expect almost anything when I come to SpaceX, but sewing machines?
Yeah, we do a lot of our own soft goods out here as far as there's different thermal blankets that you have to make. You can imagine as an engine gimbals back and forth, obviously it's going to move. Well, you need to close out that area from any type of heat coming back, any flames. So we have thermal blankets that we make ourselves. Also, what you're looking at right here, we're making some thermal blankets that go around our fuel tanks, fuel and oxidizer tanks in our Dragon spacecraft. So we do a lot of our work here. I wouldn't be surprised if you show back in a few years we might be actually making some spacesuits out here.
I want to see that want ad for seamstresses.
It would be pretty good. Actually, some of the folks we have here are fantastic. And in addition to making flight hardware, every once in a while they can get talked into by some of our shop personnel to go and make the most trick toolbox covers you have ever seen.
I'd pay for one of those.
Yeah, I would too. They look really good.
We're standing next to this engineering model that really forged the path for you to develop the actual Dragon capsule. And I remember when we were here before, there was a Dragon under construction, and I peeked inside, and I was so impressed. There was LED lighting. Now that's silly. It's like being impressed by the cup holders, right? But there was still something about that little bit of detail and the fact that, there are going to be people in here someday.
That's correct. The reason why we use light emitting diodes